Assalamu alaikum everyone. Welcome to another video of Chemistry with Sarip Sambe. In this video, we are going to continue the previous video and we are going to see the experiments determining and demonstrating the process of diffusion. Let's look at the first experiment. In the first experiment, the diagram is in front of you. We have a hollow tube, and inside those hollow tubes, it's open at both ends, so we have put a rubber bung from both the sides. One is a mineral wool, also known as a cotton wool, soaked with concentrated HCl, hydrochloric acid. And one is a mineral wool or a cotton wool soaked with concentrated ammonia solution. Now, ammonia gas has the formula NH3. And if I find out the mass of ammonia is going to be 14 plus 3 into 1 is equals to 17. Hydrochloric acid, HCl, will form hydrogen chloride gas. The formula is HCl, and the mass would be 1 plus 35.5 is equals to 36.5. Both the mineral wool soaked with concentrated hydrochloric acid and the mineral wool soaked with concentrated ammonia solution will eliminate or excrete out ammonia gas and hydrogen chloride gas. Keeping in mind the previous video that relative molecular mass is one of the factors that affects the rate of diffusion, we can compare the relative molecular mass of HCl and ammonia, and we can see that HCl is approximately twice as heavy as ammonia. And we saw that heavier gases diffuse slower and lighter gases diffuse faster. So ammonia gas diffuses faster from right to left. The arrow is moving from right to left. Whereas hydrogen chloride gas is also diffusing, but it's diffusing at a much slower rate as compared to ammonia. And once these two gases meet, you can see the reaction over here. Ammonia plus HCl forms ammonium chloride. In the previous video, we also saw that ammonium chloride is a solid, and this is a special solid because it has the property of subliming. So ammonium chloride solid, if heated, can turn into ammonium chloride gas. So ammonia is a basic gas, it's an alkaline gas, and it reacts with an acidic gas, which is HCl. So a basic gas and an acidic gas reacts together to form a salt, ammonium chloride. And in the exam, they can ask you the placement of the white ring of ammonium chloride, white solid ammonium chloride. They can give you three options. They can say position A, position B, right in the middle, position C, and then position D. And they will ask you at what position would the white ring of ammonium chloride be formed. So obviously you will select position number D because this is a distance x and this is a distance 3x. This is a distance 2x. So obviously ammonia will travel twice as faster as hydrogen chloride, and hence the distance of the ammonium chloride ring would be closer to the HCl cotton wool. So D would be the answer in that case. Let's move on to the next experiment, experiment number 2. In this experiment number 2, I have two glass jars. One glass jar, the bottom one, contains bromine gas. Bromine gas is a red-brown gas. And on the in the glass jar, on the top of the bottom glass jar is just air. Once I remove this separator or the lid in between them, once I remove the lid, the air molecules and the bromine molecules will start to collide. So the bromine molecules and the air molecules will start to collide and diffuse. Some of the bromine molecules will travel upwards, some of the air molecules will travel downwards, and there would come a time where the red-brown gas is evenly distributed throughout the two glass jars, giving a light brown color. So both of the glass jars are of a light brown color. So this red-brown gas diffused and it formed a light brown color in both of the glass jars. This is also a concept demonstrating the concept of diffusion. So there can be an MCQ on this, that what can you anticipate or what can you predict will happen after a few minutes. So you would say that there would be a light brown gas in both the glass jars. Let's look at experiment number 3. In experiment number 3, this is a diffusion case, but this is diffusion through liquids. The first two experiments were diffusion of gases. This is a diffusion of liquid. So KMnO4, this is a KMnO4 solid, and I would use a purple color for this because KMnO4 is purple. So I will take a purple color for this. You can take this purple color. It's a KMnO4 solid, potassium manganate. It's solid, right? Once I add this KMnO4 solid inside water, the purple color will start to diffuse, and after some time you would see that this would be a uniform purple solution throughout the liquid. This will be a uniform purple solution after a few minutes. So this is also an example in which there is diffusion occurring, but this is diffusion through liquids. So these are a few examples demonstrating the concept of diffusion. And diffusion, again, in terms of kinetic particle theory, is because the air molecules are colliding with the substrate molecules, and because of the collisions and the transfer of kinetic energy from one particle to the other, diffusion takes place and the particles move from a region of higher concentration to a region of lower concentration via a concentration gradient. So thank you very much. These were the experiments demonstrating diffusion. In the next video, we're going to start our new chapter. So till then, stay tuned everyone. Thank you very much. Allah Hafiz.